I want to brainstorm about a system that I've developed to basically uh, keep the air quality in an industrial warehouse much better than it probably is already. The thing is that in a lot of places you have dust in the air. Um, you've got dust in the air, and that dust is probably created by the product that you're storing. That product gets broken, it gets crushed, it gets run over by heavy machinery, it gets aerosolized, essentially. Um, and a lot of times that stuff that's in the air as dust is not good for people. So our goal is to reduce the amount of dust that's in the air, okay, or even maybe eliminate it. How do we do that when it's constantly being generated, right? Well, my system has basically two components. One of them is a evaporative cooler that will cool the air in the summer and also introduce moisture and other benefits to cut down on the dust in the air. The other unit is a floor cleaner, which will clean the floor without producing any more dust in the air. And basically, it will uh, contain any dust that has fallen to the floor that's available to it. So basically, the two components are an evaporative cooler, which is a fan unit supplied with a water source or a tank of water that has to be filled at the beginning of each day. We can add adjuvants to that, which will increase the effectiveness of pulling dust out of the air. Those are all commercially available. In addition, the system that I've devised has an ozone generator. The ozone generator serves to put out ozone, which is just O3, like the oxygen that we breathe is O2, but through high voltage, it's forced to take on another oxygen. Well, once that process is done, that third oxygen molecule is atom, sorry, is very excited to attach to something else. It's not a pairing that's meant to be. Okay, so it breaks down very, very easily, and it will attach itself to any particle that's in the air. So what happens then is that particle is then weighed down by this ozone molecule that has attached to it, and it falls to the floor. Okay, instead of just circulating around in the air, this ultra lightweight particle of dust, whatever it is now attached to this particle of molecule of ozone, which makes it heavy enough to fall out of the air and onto the floor. So think of it this way: you've got a mist of dust in the air. You've got this ozone, which is coming towards it, and they're electrically and magnetically attracted to each other. So they attach together, and all of a sudden they become heavy as a unit, and then they fall to the floor. So this is one way to get small, very small particulates out of the air and down to the floor. In addition to that process, which is very simple, their ozone generator is, commercially available. In addition to that, we are going to supply that ozone generator with water vapor. Okay, and the way that we're going to do that is through an evaporator. An evaporator is really just a fan blowing over a wet surface. And through the process of evaporation, the air that's passing over the wet surface takes away with it some molecules of water and basically turns it into a fine mist of water vapor. Now you can increase that effect by using medium that has very small pores, but the air can still flow through. And so basically you're supplying a constant supply of water into that medium, and the air flowing through it has a much more efficient chance of pulling off moisture or water molecules with it as it passes through. So basically what we're trying to do is raise the humidity. So another thing that happens, aside from the effects of the ozone generator, is when we raise humidity, we increase the amount of water that's in the air. That water by itself, even without the ozone activation, so to speak, will attach itself to any particles that absorb into the surface of the water molecule. It's because of surface tension. So if you've got a water droplet and you put a piece of dust next to it, it will attach itself. They'll bond together, right? And now that water droplet will again fall out of the air and onto the floor. Now, using a device like this, an evaporative cooler, it does increase the humidity. So if you're in a very high humidity environment, it's not going to work as effectively as if you're in a very arid or dry climate. Okay, and this changes day to day. So what we want to achieve is some medium where we're not making the air in the warehouse too humid because that would be uncomfortable. But instead what we're doing is we're cooling the air by evaporation and we're eliminating the dust that's in the air. So that's the goal. And that has to be researched and developed so that you can get a good correlation of the two effects. You don't want to have a warehouse that's 95% humidity and is miserable. Okay? What you want is a warehouse where when it's 90 degrees outside and relatively low humidity, this machine is cooling the air by maybe 10 degrees or 15 degrees, so it feels like 75 to the workers instead of 90. Okay. The other part of this system is the floor cleaner. Okay. And the floor cleaner is a very important component. After all this dust and debris is taken out of the air column and down to the floor, we then need to clean the floor to dispose of it, right? That's what we're trying to do. You can dry sweep, okay? But all you're doing is you're pushing the dust around. You're pushing the debris around. Yes, you can collect it and get rid of it, but in the process, you're also aerosolizing a lot of that fine particulate, and you're just shooting yourself in the foot by doing that. Okay, all that particulate is going to get onto your product on the shelves. That's where it's going to settle. So it's a very symbiotic relationship between the air cleaner and the floor cleaner. Okay? So every single day, this floor cleaner is going to sweep the floors with water, and it's going to pull up any debris that has been pulled down to the floor. Okay? Then we can collect it and eliminate it. So it is completely out of the warehouse. Right? We're not sweeping it around. We're not putting it back in the air. We are eliminating it every single day. So the net effect is that at the end of one day, okay, we have probably removed pounds and pounds of dust. Now, over time, over the first week or two, the floor of the warehouse will become clean. The air of the warehouse will also become clean. Okay? So now you've got a much better situation for both your product and your employees. Right? Your employees aren't breathing all this dust, which contains God knows what. Your product isn't getting accumulated with all this dust that cuts down on the viability of selling it. So together, these two simple machines, relatively simple machines, are doing a world of good for your warehouse. Okay. I don't know what kind of cost saving this is going to have as far as saving material damages, but it will be great to have a clean warehouse as opposed to one that is depositing dust on all of your products every single day.